So, good afternoon. So far, we have discussed something about the constraints. We have already discussed regarding to domain integrity constraints. The domain integrity constraints will be eliminates nulls from your data entry, and it could also apply some kind of conditions based on the situation. Some conditions will be gets operated by using the check constraint, and then so these two have been taken into consideration, and we have seen all these, and followed by we have already seen something about entity integrity constraints, the primary key, how primary key can be created, and what are the activities of primary key also seen. So primary key can be not accepted any null values, and the primary key cannot accept any duplicates. That means the combination of unique and not null will be called as primary key. And more specifically speaking, so attribute which is being enforced by the primary key will be considered as prime attribute, and this attribute will be able to represent all other attributes within the row. Okay, so it is a prime attribute which could be able to represent all other attributes within that particular row. Actually, as far as DBMS is concerned, this row will be called as this particular row will be called as entity. So one particular entity, we will see this one probably by 2 to 3 classes, or after 2 to 3 classes. So this is called as entity. So that entity information is being represented by one attribute. That attribute is called as primary key attribute. Already we have seen what kind of so activities which could be done by primary key. And then unique will be always accepted, no duplicates. It could not be accept any number of duplicates here. But one problem with the unique is, so it could be accepted any number of values, any number of null values. You could enter any number of null values, but if you provide any value, that should not be duplicate, that should not be existed before that. So these are already we have come across, and already we have seen the complete experiments also regarding to this particular thing. And now today we'd like to concentrate on a very important point. So the point is foreign key. This foreign key is playing a vital role in database management system. So because foreign key will be what is the importance of this one referential integrity constraint is, so it could be implement relationships among tables. Okay, a table must be have some kind of relationship with another table while enter some kind of data. So what kind of rules and regulations should to be followed will be defined by this foreign key here. This foreign key can be always used to define the relationships between or among number of tables. What actually been done here? So if you are supposed to take into consideration to define this foreign key, you must at least require, at least it must be required two tables. At least it must be required two tables here. At least two tables must be required here. Let me say this is A and this is B. Two tables are there, and here one table does contains primary key. One table does contain primary key. An attribute will be enforced with the primary key, and the second table must be contains, of course, primary key may be there, may not be there, that doesn't matter, but foreign key must be available in another table. So from this particular attribute, we have a relationship between these two. So stated that these two must be having some kind of relationship here. For one value of this particular primary key, you could able to define infinity number of elements or rows for this particular B. Okay, so this relationship is called as one to so many relationship. This relationship B. So from A you do have only one row, but in B, so you maybe have the relationship or the existence of B might have many. If this kind of relationship will be established, I mean this kind of structure will be established, this whole structure will be called as foreign key. relationship, establishment of foreign key relationship. Now, the point I'd like to display to you, that's very important point to be understand. So that point is a foreign key, try to remember a foreign key field in one table, in a particular table. Let me say this is the foreign key table which contained by the foreign key. It must be refers, so primary key of another table. Remember, primary key of another table, you must remember this particular point. A foreign key of one particular table. Here foreign key will be existed with B table. Let me give you a clear example, then you could understand. Foreign key does existed with the B table. This foreign key must be, so refer the values of another table of primary key. If it is not primary key, foreign key cannot be established. If it is primary key only, then foreign key can be established here. Okay, that is what. If primary key cannot be there with A, it is not highly impossible to establishment of the foreign key between these two tables. Okay, so this point is very important. This is very important point to be remembered here. It is a star mark point and underline point also while defining something about so the foreign key constraint. Then what exactly, so we have two tables. So what is the formal name of this particular table and what is the formal name of this particular table? Let us see the formal names. So if foreign key can be existed, if foreign key can be existed in a particular table, the table is called as a child table. That table will be called as a child table. So as per our example which I have drawn here, this is called as the child table. And and the table which contains primary key, so theoretically it is also called as candidate key. Theoretically it is called as candidate key, but primary key in the sense it is a practical approach kind of word, and this is a theoretical approach kind of word here. However, if the table which contains primary key, which is called as parent table, so this is called as a parent table. So parent table. Okay, so therefore, so you have three different types of points you need to remember. One more point I haven't written here, but I'd like to explain you what is that particular point. So first 2 points will be, so foreign key can be used to establish relationships between two or more tables. And second, continuation, in continuation, that particular point will be a foreign key field. Whatever the foreign key field you have with you in one particular table, it must be refers primary key in other table. It must be refers primary key in other table. This is the first point and a very important point to be remembered. And second point must be, this is the second point we have to remember. So the table containing foreign key, the table containing foreign key called as a child table, and the table containing primary key is called as the parent table. And another name also be there, parent child, another name also there, master. This is master table, and this is detailed table, detailed table, master table and detailed table also be there. And point number 3 will be, point number 3. So here foreign key is existed within this particular B table. So even then this foreign key, sometimes there is a possibility to occur. A primary key can be defined within this particular table. Okay, within this particular table, there is a possibility to define primary key also. In presence of foreign key, we have been defining one particular primary key within the same child table or detail table. Within this regard, so this primary key will be called as, a partial key. This is called as partial key. Okay, I hope that you understand what I'm speaking. It is called as the partial key. What does it mean? What do you mean by partial key? Let me explain the activity of a partial key when we will enter into the practical approach here. So 3 points you must be remember. I will repeat one more time because understanding of a primary key, foreign key is very difficult. So that is why many people doesn't understand this particular point. So that is why I'm repeating this many times. Foreign key can be used to So establish relationship between so several tables or among several tables. A foreign key must be refers primary key of other table, okay, and the table which contains foreign key is called as child table, and the file the table which contains primary key is called as the parent table. So in presence of third point is in presence of foreign key, if we able to define primary key, then such kind of primary keys are called as partial keys. Let me explain the points here. Let me explain the points in a proper way. Just wait for a while. I'll make necessary assignments, arrangements here. 24 and look at our console. Okay, let me take this one only. Let me increase the size and which could be bold. Okay. Okay, however, hope that this is visible to you. Otherwise, I will increase some more size. There is no problem for me. I'd like to increase some more extra size. So 28. Let me go ahead with 28. Okay. Look at this. Select everything from so CAT. What are the tables we do have with us? Okay. Set lines. Line size will be 100. Set the pages. Pages will be 50. Okay, let me execute the same. However, it has been displayed in the similar fashion only. So these are the tables which we do have. Let me create some tables for you. Then it is very easy to understand. So what is the specification of so this parent-child relationship here? Already master table is there. Master table, I have created master tables for you. Though I'd like to create it today also. Today also I'd like to create master tables for you. So let me see. Create. How you can enforce the primary keys and foreign keys here. Create a table. Table name is master, master. I don't want to put any other names here, only master. So open brace. Then I'd like to consider CUST, customer ID, which is the number of some 5 or 6, how many number of things will maybe. So here it is primary key. This is primary key. Okay. Then customer name. So customer name is varchar 2 of some 20. Okay. So which is not null. I must accept some values here. And then customer address, that is not important for me. Balance, which is the number of 11, 2. I'd like to define this particular table in such a way. Yes, your table has been created because there is no duplication. Table has been created. Now, customer ID. This customer ID is a primary key here. So I don't have any foreign key at this particular place. So that is why it is called as the parent table. Then let me create a foreign key table, that is transaction table. So create a table name is TRANSACTION, transaction. So first one is transaction TRANS ID, transaction ID, which is number of 5, Let me take this transaction ID must be unique value. So that is why it is a primary key. Then transaction ID has been taken. Then transaction type. What is the transaction type you have done? So character of so some 2. Only 2 characters will be taken. So here I'd like to check that check whether transaction TRANS underscore type will be in. So let us consider. So maybe withdraw capital W, withdraw in the sense capital W, or it might be having small w, any one of these two, or so deposit capital D. So people may be enter small values or capital values, or small d. So either of these 4 values only, not more than these 4 values. So if you are supposed to enter this particular data, of course, before going to take this one, not null also. Not null. Null could not be accepted. Okay. So this could be definition of the transaction type, and then followed by the amount, how much amount he has done, number of some 11 comma 2, how much amount he wanted to withdraw or deposit, however, which is also not null. So I have created full-fledged kind of tables here. Then followed by transaction T, TRRANS DAT, a transaction date, which is a date type. So followed by, if you are not interested to enter date continuously, normally if you do, if you perform the transaction today, today's date will be the transaction date. So that is why, so it is not null first, not null, and default the value will be SYS DAT, system date. Okay, so that is a function. Actually, I'll give you those functions after some other time, probably by tomorrow's class. Then finally, who did this one? That is the CUST underscore ID. Who is the customer? So that customer ID will be the specification here. So number of so 5. So here it has been defined in the parent table. It has been defined primary key, but here right now it must be defined as foreign key. So while defining this particular foreign key, so we have used references, RENCES. References itself is called as a foreign key here. References to whom you are referencing. I am referencing so master. Master is a table. Within this particular master, I have one particular column that is a customer ID. Okay, in this way you have created your table. Okay. However, default must be the first class. Where it is default. Default must be the first class and followed by constraints. While defining the column, also we have given the same. Default must be the first and followed by the constraint. Okay, that is the only point you need to remember. Default must be the first. Default must be the first class followed by constraint here. So that is why. So we got this one here. Okay. However, your table has been created. Our table has been created. Okay. Now, so look at this. Look at this. In our transaction table, there is no data so far. Select everything from master. There is no data here. Select everything from so transaction. No data is available here. In both tables, we don't have any data. Okay. So in both tables, we don't have any data. Now I am trying to introduce one or two rows within into transaction here. One or two rows will be introduced into this transaction here. Let us have a look here. Insert because its parent table doesn't have any data. So what will be the answer? It will become insert into table name is transaction. So values, what are the values I would like to insert here is so transaction ID number 1, and the transaction type will be withdraw. Number 1, withdraw is the second point. The third point is how much amount, in the sense I would like to withdraw for 1000 rupees, and then followed by date will be today's date only, SYS DATE, directly you can take system date, and followed by which customer ID. For example, I would like to consider so 100. Does 100 is available with master? No, it is not available. 100 is not available. So look at this. So it could be generated one error message, that is integrity constraint is violated, whatever the name it may be. So it is violated. What is that violation? Parental key is not found. So you have been defined a relationship between customer ID of a transaction with so customer ID of master here. In master, we don't have any data here. Nothing is there with us. Nothing is there with us. Even then, we are trying to enter some value as 100 here. 100 is not available with master. 100 is not available with master. So that is why integrity constraint is violated. What is that violation? Parental key is not available. There is no such kind of parent key that is 100. 100 is not available. So that is the point you need to consider here. So if you are not able to define this foreign key something like this, then this foreign key cannot be defined something like this, then such kind of error messages will not be there. then obviously you could enter, you could able to enter these rows without any problem, without any error messages. These things will be accepted. Okay. Now you can consider, I'd like to introduce one row into master table, insert into master values. So first value is 100, comma, his name is some Hari, balance is maintaining some 12,000 rupees initial balance. Row has created. Now row has created. Look at this. Select everything from master. Yes, one row is available with the master. Now let me introduce the same row, whatever the row I have introduced just before. Let me introduce this one. Yes, customer ID 100 is available with master. So therefore now it could be possible. It could be possible to enter. Look at this. Previously 100 is not available with the master. Right now master does have 100. So without any problem, it has been introduced. So this is the relationship between so one table to another table. Okay, one moment please. So this is the specific issue which we have to consider as far as a foreign key constraint which is being enforced here. So this is the parent table. So using this particular parent table, yes, you have entered some kind of data. If so whatever the reference column which could be maintained from the child table, that reference column will be, so always refer the values of parental value, and so-called data what you have entered here, that must be available within the parental table. If it is not available, obviously it could be produced with this kind of error message. Parental key is not found. So that is why I am omitting to introduce this particular data here. Now let me try with one more. So transaction ID is number 2, and so I am trying to perform, let me say some deposit operation, and 1,000 rupees will be deposited today only, and the item number is 101. Okay, look at this. I'd like to explain through this particular query. I'd like to explain two different types of explanations. One is related to foreign key. So here in master there is no 101. There is no data related to 101. So that is why this row could not be introduced. Now you can see, as far as transaction ID is so it is a primary key which was defined by us. Yes, it is a primary key which was defined by us. So I have followed rules and regulations of primary key here. Yes, it is 1. Previous row, the value is 1. Right now, I have strictly followed. Yes, I did not enter any null value, and I have been provided the specific value which is not duplicate with the previous values. I have been followed complete rules and regulations which have been forced by primary key. Even then, this row is not being introduced. Why it is not introduced? So because of this particular rule, the foreign key does not satisfy its condition. What is the condition? Its parental value must be existed with the master. If it is existed, then it could be entered. So the activity of primary key will be partially looking forward here. Okay, it is looking forwarded partially. So it has been followed completely. Even then, you could not able to enter this particular row into the table. So that is the specification. So that is why. So in presence of foreign key, if any primary key can be defined, such kind of primary keys are called as partial keys. They could not be activated completely. They are supposed to be considered as partial keys. And here you need to understand one more point here. So he was so number 1 again, transaction ID is number 1, and transaction ID is number 2. So previously the number 100 has been deposited, withdrawn something. Now it may be deposited at this moment with 1,000 rupees. Okay, let us have a look here. The row has been created. You can see, select everything from transaction. You can see. So for one row of master, there are several number of IDs. Same IDs will be provided are taken by the child. So that is why it is called as one to many. I have explained to you this kind of relationship is called as one to many relationship, something like this. So that is why it is called as one to many relationship. For one row of master, you may be enter any number of rows in child. That is the foreign key content table. So it is a master which does have only one row. There should not be duplicates of this. But here you can perform any number of transactions. Daily you could perform 3 transactions. So first transaction withdraw, second 2 transactions will be deposits. Yes, it is able to possible. So that is why for one row, many number of transactions could be there. So that is why it is called as one to many. So relationship here. I'd like to depict you the same in terms of by using this one. So look at this. So I'd like to take into consideration, I have already taken here. So master and the transaction, you could see, you could able to see, draw this one and place onto transaction table. So enforce enforce the integrity, and you can observe one to many. You can observe this particular thing, one to many. So create. Look at this. If you create this particular relationship, it is clearly illustrates that for one row, you can able to enter as much as many number of rows in transaction. So that is one to infinity. Infinity in the sense many. That is the meaning of infinity here. Like this, you can able to so provide this many. So these are the points I'd like to quote today. Okay, the foreign key constraints. The foreign key constraint will be taken something like this. So here we have explained what is foreign key and what is a child and what is parent and what is a partial key here. Okay, and then followed by I'd like to go ahead and explain something about remaining operations also. Okay, let me take into consideration of um, built-in functions. So there are several categories of built-in functions are available here in SQL. Let me say in SQL here. So number one category will be number one character kind of functions. Let me explain as much as many. Let me list out the points here. So character functions. So numeric FUNCTIONS. Okay, numeric functions. Then followed by date functions. Then followed by aggregate functions. Aggregate functions are very important to so aggregate functions very important. Then followed by numeric character aggregate and what is that miscellaneous miscellaneous functions. Okay, the problem is available here. Okay, so these are the different kinds of categories which are available with us. These are which are having with us. So let us have a discussion regarding to aggregate functions here. However, except aggregate functions, remaining all other functions will be work individually, independently. Okay. To define these, we'd like to introduce one system defined table which is called as a dual. Dual is a table. This is a table, so which could be gives you so how it could be considered as it is a table which could be perform the temporary operations. Okay, temporary operations are supposed to be performed by us. So I hope that everybody have some kind of idea regarding to so magic slate. So whatever the operations you have come across with magic slate, same kind of operations will be done by this particular dual. If any function could be gets operated here, these operations will be took place at the dual, and so that dual will be displays the output here. let me give you one or two examples here, then you could understand very easily. So I'd like to perform select. Uh, okay, let me mention the functions here, number functions. So that is um, round off. The function name is round off. Round off can be taken a float value. The float value can be taken, and then n will be taken. And in the sense, it is going to adjust the float value for these many number of decimal places. Number of decimal places. Let me show you this particular thing. Select. So select ROUND, round off some 12 point something. Okay, so 12.323256 something like this. Two, so this is the value which I have to two decimal places. So from dual, the table name is dual. Actually, dual is not a specific table. It is a temporary workspace. Temporary workspace. So this operation will be done at the dual, and it will be display the content here. Look at this. So it has been rounded to two decimal places here. Okay, something like this is being happening. So this is the dual is a particular table which could be works as a temporary workspace area where exactly all kinds of operations will be done here. Not exactly numbers. It could be also done something like this. Select INITCAP, initial capital of let me say, so this. Okay, this is like, otherwise let me take Newton instead of engineering. Okay, from dual. If you take like this, it should also be executed. Oh, I may be there. It should also be executed. Look at this. So I have provided completely, so all capitals. It has been provided initial capital in the sense first character of every word will be capital letter. So that is why. So it could be perform any kind of operation, whatever the operation it might be. It can be it can be provided any kind of operation. Look at this, any kind of so operation, both characters, var to integers, date, whatever the operation it might be, it will be provided any kind of operation here. So if you define describe dual, if you go ahead with dual, look at this. So this defined definition will be, so dummy is the specific name of the column and which could be taken var2 of 1. And if you select everything from a dual, if you select something like this, you could see the name is dummy and X will be the specific value, default value which could be stored here. So it is a temporary work area where exactly the operations will be done here. So I'd like to list out the specific, where it is. Yeah. So this could be works based on dual, and of course tables also. This could be works based on dual, and date also be could be work on dual. Of course, you could specify specific tables also. Not only dual, you could also specify specific tables also. For on your table, you could operate those operations and all those things. Miscellaneous could also be operated dual or specific table. There is no problem at all. But these must be aggregate functions must be operate on only user tables. User tables only. Okay, you must remember this particular point. So aggregate functions could be gets operated on users table only. So without user tables data, aggregate functions could not be so get work out here. And you have a 8 marks question in our final examination. So stated that aggregate functions could be always as and when aggregate function will be there in our selection. So group by class will be evaluated. CLAUSE. Class will be evaluated. So class will be taken into consideration. CLAUSE will be taken into execution. Okay, so aggregate functions will be always executes based on the group by class. So when situation demands, we will work out everything. So tomorrow I will list out all the functions which are related to character kind of functions, number kind of functions, and date functions, and miscellaneous, and also aggregate functions. Everything must be listed out, and probably by tomorrow we will finish off all these 5 different kinds of functions. So then after we will go ahead for the assignments as like as Unix programming. So this is what the point today I'd like to explain to you. Okay, tomorrow we'll meet back.